Hey everyone, thanks for joining the office hours for failure flags. This is the next in our monthly series of office hours calls. Today we'll be talking about how to test serverless apps or applications using failure flags. I'm Dan Muir. I'm a senior solutions architect at Gremlin and joined today by Mr. Jeff Nikoloff, who is a principal engineer at Gremlin and ultimately responsible for failure flags, product roadmap, feature functionality, all that good stuff. This will be recorded. It'll be posted to the gremlin.com/office hours afterwards. And if you've registered, I believe you'll get a link to the recording in your email as well. Like this to be as interactive as possible. So as we're going through, feel free to throw comments in the chat, use the Q&A panel if you have any questions, and we'll get to those either during the presentation and demo, or we'll definitely have time at the end to cover any questions. So we'll just kind of jump right into this and kick this off. So quick agenda for today. What does serverless application reliability actually mean? How does Gremlin support serverless testing? Then Jeff will run us through a quick demo, kind of how to get started with failure flags and what that kind of looks like to actually execute an experiment with failure flags. And then we'll have time for Q&A at the end. So starting off right, we'll kind of jump into, this is a simplified graphic of the shared responsibility model for AWS Lambdas. It lets you really deploy applications without having to worry about all the physical hardware, all the operating system, all the runtimes. All that is managed by AWS. So all you really have to focus on is your code and your application. So what does that mean to you then is your responsibility is this top section. So really just your code and some of the things that you want to focus on in terms of reliability risk in this type of environment is some things like resource exhaustion, right? How does your app handle limited resources? How quickly and efficiently does it scale? Do you have redundancy? Do you have redundant instances running? Again, this is specific to not the underlying hardware, but redundant instances running at the same time that you can load balance requests between dependency connectivity. What happens if you have limited or lose connectivity to any dependencies? How does your application respond to that? DNS resolution, do you have primary, do you have secondary DNS? Have you tested what happens if the primary fails? Does everything fail over correctly to the secondary? All that good stuff. And finally, public network connectivity, right? What happens when your app can't connect to anything? Do you have load balancer setups to redirect that traffic? Do you have, 404 or 503 pages? What is that user experience ultimately like? And how do we test and view that? So moving on to kind of how failure flags work. So at a high level, you add the failure flag to your application code using one of our SDKs. This is basically an entry point to inject faults into your application. So this is like adding latency, doing exceptions, that sort of thing to your code. If there's nothing running, this is basically just no op. It has no impact to your application, but it gives you that entry point to be able to call those things. This SDK doesn't actually communicate with the Gremlin servers. That's all handled by the sidecar that is spun up by this. And then the failure flag impacts your application instances. It can be used to recreate failures within your application or between your app and its dependencies. So that's why kind of here we show putting the failure flag, at the point in your application where you call out to your database. So that gives you the ability to impact that dependency directly. All right. So here's the steps: deploy the SDK, deploy the failure flag sidecar, and then start the experiment in Gremlin. So this is kind of nice. It allows you to just change and put those pointers into your code, and then you control all the experimentation from inside the Gremlin UI without having to make any further application changes. All right, moving on, we will talk about a quick example of a network outages. Typically in a traditional infrastructure, chaos engineering, reliability engineering tool like Gremlin, you'd run a network fault to drop the IP packets, maybe fine tune it by targeting specific IPs, host names, that sort of thing. Um, when failure flags, the fault is injected inside the application. So in this instance, we can throw the failure flag at this point, cause the failure at that connection, going to DynamoDB, and be able to inject latency, cause failures, exceptions, those sort of things. So it gives us a lot more fine-grained control over this and allows us to do this in these serverless type of environments. And failure flags isn't just for serverless. It works anywhere where we can have basically containers and sidecars. So there's a wide array of areas where this is applicable. We've had conversations recently around PCF and all the different cloud environments and Kubernetes. So I mean, there's all sorts of environments where this can be applied. But for purposes of today, we're going to keep this kind of simple and focus on just serverless and Lambda. So with that, I will stop sharing, pass this over to Jeff, and I will check on the chat and see if there's any questions.
Any questions? Everybody saw the slides? Sounds like Abdul may not have seen the slides. Okay. There's a couple of things that I like to start with and really reinforce in these presentations. The big question for me has always been like why, and one of the reasons why I came on to help build this product. Infrastructure level testing is really great for the most critical types of failures, right? Those things like the network going down, where like this is a really easy one for us all to have lived through and experienced some of that drama because it's such a critical impact to the business. And so shoring those things up, understanding how our systems behave under those very, very critical situations is a sort of a no-brainer, right? But it's a relatively small piece of the pie. What application level fault injection is really all about is about testing those same situations in serverless environments, but also, and I believe, maybe more importantly, is testing those types of errors that we encounter every day, right? Especially as we build more and more complex systems with microservices, things like that. 85% of the errors that we encounter are application level errors. They're broken API contracts. They're unexpected data flowing through the system. They are ill-timed deployments. Other like just microservice availability issues that may or may not actually be related to network. So like this very big part of the curve is actually the very long tail of application level concerns, and infrastructure level testing provides very limited ability to test those things. At the application level, you can target based on application level data. So you're not just targeting a host that's for experimentation. You can say requests to a host from a specific user or for a specific database partition or based on the kind of request or the data that comes in, right? This application level targeting, which really opens up a whole new world of like real world failure modes for testing. So I just have to hammer that home. This is for the failures that we really do experience every day as engineering organizations. With that, let me jump into a quick demo. So share my screen. Okay. So here's the Failure Flags web console. Failure Flags right now is sort of its own isolated product within Gremlin. That's going to change over time. We have it currently on our roadmap to integrate this with the rest of our testing capabilities, to integrate it with scenarios so that you'll be able to build scenarios that include both infrastructure and application level faults, which we're really excited about. But today this is what we have when you show up. So you say, okay, great. I want to use failure flags. Where do I start? Well, right here up at the top, we say the first thing you've got to do is connect one of your services and annotate your code. You can flip-flop the order here, but you won't be able to verify that you've annotated your code correctly until you connect your service, which is why we suggest that you start that way. So what connecting your service means is this is where you're actually going to add either for Lambda, the Gremlin Lambda extension to your code, and this comes in as a Lambda layer, right? So you add a Lambda layer to your Lambda, you provide the configuration details, which include things like your credentials, etc. And then you deploy your Lambda with that. Now, once that happens, your Lambdas will show up down here, and I'll show you what that looks like in just a second. Once you then add the failure flags SDK, in this case, we're going to use JavaScript, so I can show you this really, really quickly. So this is the JavaScript, the Node SDK for failure flags. Anyone can go look at this. It's Apache 2. The SDKs are fully open source. They're very, very small. You might notice that even the Node SDK has zero third-party dependencies, so it's a very, very simple and clean software supply chain for adoption. Instrumenting your code, you're gonna make two kinds of additions. You're actually gonna bring in failure flags as a dependency, and then you're gonna add a failure flags to points in your code where you want to be able to inject failure. And I'll show you what that looks like. So here's a very simple Lambda function. All this Lambda function does is it responds with some JSON saying how long it took to process a request in milliseconds. What that looks like is, if Zoom would get out of my way, what that looks like is this. So as I sit here and refresh this, we can see how we got a cold start. Refresh it again. Now we're down into, a low number of milliseconds, right? This is all that this code does. Now, if we come back to the code, we can say, well, where's the failure flags piece? All we've done here is we brought in failure flags again, and we have added a failure flag to our code. Now, where we've added it is pretty much right at the very beginning of our processor. And we're going to give this place a name. It's really what we're doing when we're adding failure flags. We're saying this spot, this failure flag, in this example, called this HTTP ingress. Now, that's not a magic name. There's nothing magic about how you name these things. It has semantic value to me and to my team. So you might call it something completely different when you're adding it to your code. The other thing that you're doing, or that I do in this example, is we add some label metadata. Now, if this provides a name for the pointing code, what label metadata does is it allows you to bring dynamic context on a per invocation basis. And what we're doing here is we're saying we're identifying the pointing code and attributes of the current invocation to determine whether or not this invocation should break, right? So as the code flows through, it's going to come in and it's going to say, hey, oh, we've encountered a failure flag. Is there any experiments targeting this? If there are, then it's going to carry out that experiment right here before it proceeds. And we'll show you what this looks like in live. So here we've got our this is exactly that app deployed. Come switch over to the team that I have with the demo. Here we go. Now, this app specifically is called failure flags examples main node demo. That's just the name of the Lambda function. We can see that it's active. We can see that it's a Lambda function. We can see that it's contributing a failure flag called HTTP ingress. All of this is, pretty much keeping consistent with what we've talked about so far. And now that those two things are there, we get to carry out the third piece, which is creating an experiment. Now, I happen to have an experiment already, just happen to have an experiment already created for this, but let's talk through it real quick. An experiment consists of three pieces. It consists of a failure flag selector. This is where you're telling the experiment where, again, like where in the code you want to inject the failure and on which invocations. The second piece is the service selector. Which service do you want to run an experiment on? In this case, I called out that Lambda function very specifically. And the third piece is an effect statement. Now, an effect statement, we get to specify the duration of the experiment. In this case, I'm specifying 5 minutes. We also have a probabilistic roll of the dice to see whether or not matching invocations should receive the treatment. In this case, I say 100%. If it matches the selectors, then definitely carry it out. And the last piece, we describe the impact that we want to have. This effect statement specifies that we want to inject 1,000 milliseconds of latency. Very straightforward, a little bit of JSON, nothing to worry about. So what we expect to see when I click run is for this Lambda function to take a little bit longer to render and to show up as having added a flat second to the standard amount of latency. So let's go ahead and do that. Click and run, verify that we really want to do this. Yep. All right, now what's happened is it's marked this experiment as active. Back over here in the experiment, that sidecar, that or Lambda extension, periodically phones home to find out. I think by default it's every 30 seconds to find out whether or not there's any experiments, targeting this Lambda function. Now, that's not a direct call. There's nothing. It is not in your code path or your critical path, anything like that. It's out of band. So there's never any impact to your software unless there is an experiment and you are targeting it. So here we're going to start refreshing it. Oh, there we go. Boom. We can see we get a little bit of spin up there and we get a flat full second added to our standard bit. Now, great. We've seen the impact. If this is part of a larger experiment, we might see, hey, how does slow down of this Lambda function impact the rest of our system? Might do a little bit of, tracing around in our observability system to see, are our monitors triggering? How is this impacting other consumers that have a dependency on this? Is everything still okay? Once we've learned what we need to learn about our system, there's not a whole lot of reason to let it go longer than it needs to. And so we can always come back in here and halt the experiment. We can either do that directly here, or if someone's being paged and to say, hey, we don't know what's going on, they can always come in, hit the halt all button just in case one of these experiments somewhere in Gremlin is having an impact in a sensitive system. In this case, that's not what's happening. I'm just going to halt this experiment. Let that go. The experiment should be halted. Now, sometime within the next 30 seconds, this will have recovered. Boom. Already done. Now we're back to normal. Everybody's happy. We've learned something about our system, and all that without any control over the underlying hardware. No kernel level integration. It's just very, very straightforward application level integration. Now it was a lot, so I'm gonna pause for a moment and see what kind of questions the group has for me.
Yeah, if anyone has questions, if you want to raise your hand, I can unmute your mic and you can just ask a question. You can also throw things into Q&A and to the chat.
Looks like Paula had a question. By serverless, do you mean Kubernetes and containers? How does that work pricing wise? Your sales rep told me pricing is server agent based. This is a great question. So by serverless is a very large category. Where failure flags is concerned, it's really wherever you end up running failure flags, right? So in this example, we use Lambda. You can absolutely deploy this in Kubernetes anywhere where the sidecar can run. We actually are in the beta process of an Istio integration as well. So we'll be able to basically skip the software level instrumentation as well. So how does that work pricing wise? So pricing wise, yeah. So the server agent based is kind of, it is agent based. The big question that everyone always wants to ask is, well, how does agent based work in a world where we're attaching an agent as a partner to every one of our processes? So we're sensitive to that. You get a whole lot more value out of a single, host agent than you do for single processes. And so basically what we do is there's a handful of labels that come in off of the actual, like sidecar instances. And we aggregate those things. So, but Lambda is a really easy one to talk about. So we aggregate it based on service and the like basically the count of services and the number of ways it's deployed. So Lambda, very straightforward. You really only have regional level control on Lambda deployments. So if you have, one Lambda function that is deployed in one region, that's one agent. If you have two Lambda functions that deployed in one region, that's two agents. If you have 10 Lambda functions that are deployed across four regions, then that's 40 agents, right? So no matter how many individual instances of those Lambdas pop in and out of existence, we're not going to bother you with accounting at that layer. You don't have any control over the number of those things that are popping up. And so we're not going to like introduce that level of unpredictability in your billing. So it really is on these very controllable dimensions with respect to deployment. Does that answer your question, Paula? Awesome.
And there's another question in the Q&A for you, Jeff.
Can you read it to me? I'm not sure I can see it.
Yeah, it says, can you perform the test without injecting anything into the code and only use the layer so that your code can remain clean, or do you have to always inject some code so that you can perform any test?
So there has to be some integration between your code and because it's the SDK that carries out the experiment, right? It doesn't happen outside of it. With the service mesh integration, then it does because it happens in this network middleware that is happening like outside of your code. But that also means that there's only very specific types of experiments, network type experiments that can really be carried out. So yeah, it has to be in your code. The good news is that it's very, very simple. Like we designed this to be a lot like feature flags, and the library itself is extremely extensible. And there's also all sorts of ways that you can pull it in a very clean way. It also means that we also designed it to be extremely fail safe so that you can feel comfortable, not only comfortable because you know what it's doing, but comfortable adding it to your code and knowing that it will have no impact unless everything is set up correctly. And by everything, I mean the SDK has to be present, has to be in your code. It has to be able to, like, it has to be specifically enabled via environment variable. The sidecar has to be deployed. The sidecar has to be configured. It has to be specifically enabled. There has to be a route from the sidecar to Gremlin. And the credentials that it has have to be valid. If any of those things stop, or if any of those things are misconfigured, then it can't have any impact on your application at all. It's also open source. We don't want to, basically tell people that if they stop using, if they start using this, integrate it with their code, and then they stop, that they have to go remove failure flags from their code base and create some kind of scramble. That's not the case. That's why we chose to make sure that the library itself is extremely simple, is a very clean supply chain, and that it's open source, right? This is, very, very good license for our customers. But yeah, you have to include it. For our larger customers that have, let's say you have thousands of applications where you want to be able to use this, and you don't have the time to go through every single one of those and figure out where you should put it in your code. In those cases, we found that, very frequently those customers have internal service frameworks that are, common across a lot of applications. And so, they've had great success adding it broadly using, by embedding it in those frameworks. So like individual applications really don't even need to worry about it if you have something like that.
All right. Um, Explanation of what the actual sidecar do we install and maintain this sidecar?
So the sidecar itself is a very small process. I think the file last I looked is like 7 or 8 MB, depending on the architecture. Um, and it is extremely small memory footprint wise. I think the most memory I've ever seen it consume is about 80 MB. And its sole purpose is to serve requests that come from the SDK and maintain a cache of experiments that it periodically refreshes from the server. Um, that's it. So basically, every 30 seconds or so for long-lived processes like you might see in Kubernetes, every 30 seconds, it sends a request to Gremlin to say, hey, here's who I am. Do you have any experiments that are targeting failure flags on me? And if so, it receives a small JSON blob back describing the experiment, and it keeps that in memory. Then the next time the SDK reaches out and it requests that thing, it can just hand it back. So it's very, very small, extremely lightweight, and really designed to be out of the way. But it buys you a very important decoupling, but from your software's critical path and that synchronous request to Gremlin, right? So that is always out of your way.
All right. And see, does it add any extra cost to your Lambda?
Like
Okay.
moderately. Like you're gonna, I mean, it really depends on how your Lambda is configured, but there's no upsell in AWS for using Lambda layers. There's no upsell for using extensions, anything like that. We certainly don't charge you for consuming the extension. Um, that's not, I would be really surprised if you saw any meaningful increase in cost.
Let's see. Emmanuel put in chat that they don't see the failure flags. So depending on when your license was renewed and what license model you're on, you may or may not see the failure flags. Our current license model is kind of like an all-inclusive, so you will see that. But if you don't see that, it's just not enabled for your account. So easiest way to fix that is just to reach out to your account executive, and we can get that enabled for you. All right. Any other questions? We got a few minutes. We can answer some more questions. Again, feel free. Oh, okay. Been asked kind of a follow up on the sidecar question, Jeff. Where does that sidecar run and who maintains it?
The sidecar, so the the sidecar process itself. So in Lambda, it runs in your Lambda function memory, like in your Lambda execution. But it's brought in via Lambda layer and it runs as what's called a Lambda extension. So it's just a separate process within that extension. We publish versions of that layer every time every time we release the software. We publish that software several ways, but probably the easiest way to consume it is via Lambda layer. Um, the with respect to maintaining the 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 process or like making sure that you're up to date, there's a lot of the questions that comes in like that would are like around what your CI/CD process is, what your process is for maintaining your dependencies, things like that. But with respect to like maintaining it, there's not much to do. Like the only real variables that you need to worry about are making sure that your credentials that are tied in are up to date. And there are some very, very flexible ways to configure this. You don't have to use environment variables. You can bring files. You can integrate Gremlin Lambda into your own layers if you have some type of like layer lifecycle flow that you want to like integrate that with. And you can also bring in configuration via AWS Secrets Manager, or parameter store. In the like a Kubernetes sidecar world, it's a very similar story. We provide images, just container images, that you will have to add those sidecars to your deployment descriptors and replica sets and your pod specs. But um, like with respect to the piece itself, it's extremely simple. Like we don't even ship shells inside the containers. It's single file images built from scratch. So very, very lightweight. There's just not enough moving parts to require much meaningful maintenance other than periodically upgrading.
All right. I think that is it. Last call for questions. Otherwise, I have up on the screen here the the link for the Gremlin trial and the link for the failure flags overview, as well as the link for the office hours calls. We'll be doing another one next month. And if there's no further questions, we'll call it a wrap. Thanks everybody for joining. Thanks, Jeff, for hopping on and helping out. And
My
we'll
pleasure.
catch everybody next month.
Talk to you next time.
Thanks.